Okay, now let's discuss concentration in detail. That will give you the explanations that you would need to give in any of your questions to deal with concentration. So first of all, what happens if concentration of the reactant is reduced? By the Chateliers principle, we would need the reaction to replenish the reactants that are reduced. Therefore, the reverse reaction would be favored in order to give us more reactant and less products. So that is how it goes. Then what happens if the concentration of the products are reduced? So if concentration of the products are reduced, that means that the forward reaction needs to be favored in order to give us more products that were reduced and to reach a new equilibrium. So that is what the Chateliers principle says. Similarly, if we increase the concentration of the reactants, that means that the reactants need to reduce. So more of them will react to give us more products. So the forward reaction is favored in that case. Then in the case where the product concentration is increased, then we would find that the reverse reaction is favored in order to reduce the amount of products present in that particular system. Now, please do not forget that concentration is equals to number of moles divided by V. But now don't forget that number of moles are also to deal with mass. Number of moles are also to deal with volume. That's why we said please revise your stoichiometry. My point here is that if they tell you about decreasing mass or increasing mass, it directly translates to increasing and decreasing of concentration. Similarly, if we are dealing with gaseous or volume of liquids or gases, they might talk about increasing volume or decreasing volume. That is exactly the same case. Remember, here we're talking about volume of the substance, not volume of the vessel itself. That's something totally different, which we'll go into. Now we are going to look at temperature. Now, to understand temperature changes, it's essential that we go back to some concepts that we learned in grade 11. Now, we need to understand what we call the enthalpy or the heat of the reaction. That is, the change in energy when the reaction takes place. It can be found by looking at the energy of the products and then minusing the energy of the reactants. Now, what do we get in those particular cases? The first case is we could find that the enthalpy or the heat of the reaction is positive. So what does this mean? It means that there is more energy in the products than there were in the reactants, which means that the products have absorbed energy from the system, so the system would be cooler. That is important to understand. The system would be much cooler or we'd have a lower temperature because energy was absorbed into the products themselves. Okay, now what happens if we have the other case now? The heat of the reaction is negative. Now that would mean that the products have much less energy than the reactants. So how does that happen? It happens when the reactants have lost energy in the formation of the products, which means that heat is released or energy is released generally in the form of heat. So that would mean that the environment or the surrounding would get hotter. So that would be the exothermic reaction. So when heat is absorbed, we refer to it as endothermic. We have the heat of the reaction positive, and then we have exothermic, where the heat of the reaction is negative. It is essential to understand this because the Chateliers principle to deal with temperature requires us to know which one is exothermic between the forward and the reverse, as well as which one is endothermic between the forward and the reverse. So you'd always have to pay attention to these particular symbols or expressions. Okay, let's go and look at the Chateliers principle now. Okay, now with temperature, we need to understand the following again. When temperature is increased, so the first case, if temperature is increased, then we will have a case that by the Chateliers principle, the reaction that decreases temperature needs to be favored, which is the one that absorbs temperature, therefore the endothermic one. Now, whether it's the forward or the reverse, it depends on the reaction. Just remember that. You're looking for the endothermic, whether it's reverse or forward, depends on what reaction you are having. Then, if it happens that the temperature is then decreased, so in this case, that would mean that the reaction that increases temperature needs to be favored, which in our case would be the exothermic reaction. So the exothermic reaction will then be favored by Le Chateliers principle in order to increase the temperature. So more energy is released in order to increase the temperature. So temperature issues, you need to know which one is your exo, which one is your endo. Let's take this example for just better understanding. So we have sulfur reacts with oxygen to produce sulfur dioxide. Now, that symbol is given to us to show us that we are dealing with an exothermic reaction. And when they do that or say that or write that, it means that the forward reaction is exothermic. But this automatically means that the reverse reaction that is occurring, remember these are reversible reactions, the reverse reaction is definitely endothermic. So if temperature is decreased, the forward would be favored in this case because it's exothermic in order to increase the temperature. But if temperature is increased, then the reverse would be favored in order to decrease the temperature because it's endothermic. By Le Chateliers principle, it would be opposing the change done. So please, when it comes to temperature, you need to know your exothermic, endothermic, you need to know your signs. You can't mix them up because as soon as you do that, you get the opposite answer. So that's what we have for temperature. Now we are going to look at the last one for the effects, or second last one. The last one we'll just touch on it. We don't need to explain a lot. Now let's discuss pressure. Now, in order to understand pressure and its influence, it's important that we go back and have an understanding of how pressure can be changed in a system and the relationship between pressure and volume. Now, please understand that pressure is inversely proportional to volume. So that tells us that if volume, that's the volume of the container, if volume increases, pressure decreases. If volume decreases, pressure increases. Please take note of that because that's how we're going to be changing around to influence pressure. Now, what is pressure? Now, pressure is the result of continuous collisions of a gas molecule or gas molecules with the inner walls of a container. So this one you can see it in the case of when you are boiling something, whether it be a pot, whether it be a kettle. At low temperature, it's not moving, it's quiet, that's it. But as you get to boiling temperature, when it starts boiling, it starts shaking, it starts making more noise. Why is that? That's the gas particles hitting the sides of the particular container, whether it's the pot. That is where if you have the lid that is quite thin and less heavy, the light one, you'd find the lid itself doing this motion, vibrating, because the gas molecules are hitting it quite hard. So that's what we call pressure, that if it wasn't strong enough, it would hit it and it go over. So that is pressure. So now, what does that mean? That means that when Le Chateliers principle is applied, we would look at the formation of the amount of gas in the reaction. Now, in the case of that, we would be comparing the gas moles. So let's take a look at this example and use it to explain. You can write down the effect. I will just explain what happens. So here we find ourselves with an equation that has to do with the reaction of nitrogen N2 gas, that's nitrogen gas, together with hydrogen gas to form ammonia gas. So here all of them are gases. Then when we look at the forward reaction, the ammonia produced is 3 gas moles, whereas the reverse produces 1 plus 3, which is 4 gas moles. So this is telling us that the reverse reaction is giving us more gas, so it would be increasing pressure. Then the forward reaction is giving us less gas moles, so it would be decreasing the pressure. So which would mean, according to Le Chateliers principle, if pressure is increased, the forward reaction would be favored to give us lesser gas moles and decrease the pressure. Whereas if pressure is decreased, then we would find that the reverse reaction would be favored to give us more gas moles and therefore increase the pressure to reach a new equilibrium. And please do understand that in the case of pressure being increased for number 1, that means that the volume would be decreased, and that is why this one would be favored, the forward. Where the reverse is concerned, this would be the case of the volume is decreased in order to increase the pressure, the volume is increased in order to decrease the pressure. Therefore, we are finding ourselves with the reverse being favored in order to increase the pressure back to a new equilibrium or towards a new equilibrium. So please do understand that when it has to do with pressure, you need to know your gaseous moles. If solids and liquids are there, ignore them. They don't count at all, because we are looking at the gas that's being produced. Which one gives us more gas moles? Because the more gas moles we have, the higher the pressure would be. And then the less gas moles or the lesser gas moles we have, the lower the pressure would be in the system. Which is why we are saying that an increase in pressure favors the one that produces lesser gas moles. A decrease in pressure favors the one that produces more gas moles in order to increase, by Le Chateliers principle, of course. Please don't forget to quote that. So this is the case. In the case of a catalyst, just to wrap it up, catalysts are special, which is why we're not even going to go into great detail about them. Catalysts would have an influence or an effect of increasing both the reverse and forward reaction rates. So we would just end up with a higher equilibrium rate for both forward and reverse. So we can't apply a Le Chateliers principle to that. It's just a matter of it just stays constant because both are increased